get the same CSV of NACHI MZ07 6-axis roller. On the screen, you can see the NACHI MZ07 roller. This is provided by the company named Odea, which are the agent to sell the NACHI roller. We are invited to use this roller. That's the reason why we have the IGS of MZ07 roller. But after we adopt this IGS file, we found maybe the CAD system is different from SolidWorks or Panasonic core system, maybe designed by UG or Kadir. All the surface create the roller, no object at all. And there are plenty of gaps or loss of surface. After translate the IGS file into polytrans, some arc surface not good enough to show on the screen, but we can accept the model because we still can see clearly the whole robot, although a little ugly. Right. We do the SOP for the system. Whenever we get the IGS file from the customer, the first of all, we have to translate it into the local PRT file or assembly file. We have to make sure that the NACHI MZ07, the file folder, is correct, and use IGS style to see which one IGS is the original given file. Okay, MZ07.IGS is the original given file when we opened it by SolidWorks. The system translates the data from IGS into the local code. After translations, the geometry model will display on the screen. Then we save the whole mechanism first, and then separate it into individual components. There are 6 axes to control the robot, including the foundation. Basically, there are 7 big components. We do it starting from the foundation, and then the first axis, the second axis, until the 6th axis component. Whenever we separate and get the individual component, we have to save the PRT file and save the IGS file. After the 7 IGS files saved, we still have to handle the tool. Suppose we choose the same tool to do the CO2 MIG-MAC welding. Then we have design a tool original in TCP origin, then we can put the tool to join the TCP original points, and then we can save the tool PRT file and the tool IGS file. After the whole IGS file created, then we leave SolidWorks and open Polytrans to import the IGS file starting from the basement and create the positive X file and a negative X file. And then combine the positive and the negative X file into the result X file. The 7 components, including the tool, has to be translated from IGS file into X file. Then we copy all the S file into CMS CAPP data file folder and filling into Excel CSV file. That's the procedure we have to do. Okay, the IGS file already on the screen. Let's see first. Let's survey it first to see if it is correct. That means it's no need any rotation, only shift. The first of all, we have to put in from base surface to see if the model in XY position. That means the Z is top to point to the sky. Fortunately, we get the MZ07 model in good position. This is X, this is Y, the top is Z coordinate. It's okay. Well, you can see in here some surface losing. Okay, we continue. After saving, we continue doing the separation of individual component. So how to save? Use file, save file. You see, this is not the assembly, this is part. The whole model is created by surface. We save the same name, MZ07.prt. Okay, save. After saving the whole mechanism, then we can separate each individual component driven by different axis, driven axis. Okay, we start from the basement. How to do it? We put the cursor of the mouse on the basement and press the left button. The component will be highlighted, and the chosen one is highlighted in here as well. And we press input 2. You can see the whole components highlight here. That means we just keep input 2 and remove the rest of the input. to get the only individual foundation, and then change the color into yellow, and save PRT file and save IGS file. Okay, how to do it? We remove the biggest first. This is one. We remove later. So how to choose so many input? We just put the cursor on input 3 and tap left button of the mouse, and he will mark the input 3, and we pull the middle wheel of the mouse until the last one, and put the cursor of the mouse on the last one. Before press left button, together with shift button of the keyboard, press together. Then the system will mark from the input 3 until the last one. Okay, how to remove the marked parts? Simply press the delete button of the keyboard and give delete everything. The second button, press the mouse down, and the system will take times to remove all the highlight parts and leave input 1 and the input 2. We'll keep input 2 on the screen, so we just choose input 1 and press the delete button and choose yes. So only the foundation on the screen. Then how to change the color of it? Just put the cursor of the mouse on top of it and press the right button of the mouse and choose Outlook and choose the whiteboard. Then the chosen color will appear on the screen. We choose any one of the yellow and put the bar down and the correct pixel of red 255. Be input by keyboard. The green is 255 as well. For the pure yellow, we have to give the blue pixel 0. Then make sure that we can get the foundation in yellow color. Okay, after that we just save an additional file as PRT file and give the name MZ07 PRT, save it. After MZ07.prt saved, then we have to save an additional file as type IGES and give the name MZ0 IGES, save it. Okay, after save, then we do the next one. How to do the next one? We have to clean the screen first. How to clean the screen first? Then we close the file. The system will be cleaned automatically. Then we open the whole robot mechanism just to see here MZ07. Press the left button of the mouse to open the whole robot, and then the same we do the first component, J1, controlled component. The same, we just put the cursor on top of it and press the left button. Then the pick will shown and highlight in here, and we press input 1 to see this one, and the same should delete input 2 until the last to keep this one, and change the color of it, and save MZ1.prt and MZ1.igs. This MZ2 as well. This MZ3 the same. This MZ4 the same, and MZ5 and MZ6 we have to be careful. The reason why, because MZ6, MZ7, okay, it is separated. It's not the tensor. Tensor is in the same. It's combined together. If combined together, we have to separate MZ5 and MZ6 by ourselves using SolidWorks function. Okay, this is individual. We just doing the same way as MZ4, MZ5, MZ6, the same. So we can separate every component and save every component into .prt file and .igs file. After the whole IGS file, we have to do one thing, is to put the tool on the position of the TCP original. How to do it? We simply close the file and open and vacant assembly file. And insert the component, the last one, MZ6. Open it and put it back at its original position. And to find the TCP origin, we put the cursor on the edge in here. The orange rough line reflect. We simply press the left button of the mouse. Now he said diameter 43 millimeters. The center 473 0720. We have to mark it. This position is the position to locate the tool. Okay, we write it down on the paper. 4730. Y is 0 and Z is 720. Okay, how to do the location? Locate the tool. The first of all, we have to use insert component. Insert which component? Insert tool component. From where? From the very beginnings, we design the tool at the Eurotech, the folder, and open the tool's PRT file, R tool, and open it at its original position. Where is its original position? We can see is in the original position of the Cartesian coordinate in here. Okay, then we have to move the component to the original TCP points. How to do it? First of all, we have to remove the fixed mark. How to do it? Press the left button of the mouse and choose floating, and the fixed mark removed. And then how to move the component? We have to choose the component first and choose the move component function and select from data XYZ and correct the data X value by given 473. Y is 0, don't change, and data Z is 720 millimeters. After everything correct, then we adopt it. The tool will jump to the TCP original. Okay, then we can see the TCP position. You can see 243.3 Y0 Z minus 25. That means from here to here, the X coordinate is 243.3. The Y no movement. The Z down 25 millimeter. That means from this position down here 25. And rotation RX0, RY 30 degrees, RZ 0. We have to take a record of the 6 parameter before feed in CSV file to change the tool parameters, 6 parameters. Okay, we mark it already. So we continue doing the tools PRT file. How to do it? We just remove the MZ6, pick it, and press the delete button of the keyboard, and then let the tool only on the screen, and then save additional file. Save PRT first, and then save again the IGS file. Okay, after all the IGS file finished, then we have to use polytrans to translate those IGS file into S file. We started from the foundation. How to do it? Use translate function, select import 3D geometry, select IGS v 5.3 via Okino ASCII file. The folder D NACHI MZ07 correct started from the foundation MZ0 IGS. Open it. Okay. After translation, the IGS file into the geometry model of polytrans, the model will display on the screen. The SolidWorks gives 4 views to display the model. You can see on here MZ0 on the screen. Then we save the positive. Use export 3D geometry direct file. The positive, these two items, now the pick. Okay. And save the positive MZ08.x. Save it. After the positive saved, then we have to save by using export 3D geometry direct file. We have pick reverse optimization of all polygons and normals, and pick flip polygon normals. Okay. And save MZ0B.x, the negative parts of the foundation, and save it. After the positive and the negative parts of the foundation saved, we have to reset scene, no saving, and to use import 3D geometry direct as file to set the correct folder to NACHI MZ07, and input MZ08.x, the positive parts of the foundation, into the screen, and then import 3D geometry direct as file MZ0B.x, import file. Yes, so MZ08 and MZ0B.x on the screen. Then we have to save the combination of negative and the positive parts of X file. How to do it? Simply by using export 3D geometry direct X file. We save the positive normal direction. Okay. And give the name only MZ0. After that, MZ0.x be saved. The same, we're doing the same procedure to get MZ1.x and MZ2.x, MZ3.x until MZ6.x, and the last one, MZ2.x. After all these X files created, we'll have to copy MZ2.x, MZ6.x, MZ5.x until MZ0.x into CMS GAC data folders, and duplicate a CSV file and correct the whole 3 parts items of that CSV file. Then we do it right now. First of all, we have to go into the CMS GAC data and MZ start CSV. Okay, we copied one and rename to MZ7 new, and press 2 times of left button to open the file. Then MZ0 X file fitting in here. Give mesh 0, object 0, attached to 0. MZ1 mesh 1, object 1, attached to object 0. MZ2X mesh 2, object 2, attached to object 1. M3.X mesh 3, object 3, attach 2, object 2. MZ4.x give mesh number 4, object number 4. Object number 4 attached to object 3. MZ5.x give the mesh number 5, object number 5. Object number 5 attached to object 4. MZ6.x fitting in this position and give the mesh number 6. Give the object number 6. Object number 6 attached to object number 5. And then MZ2.x give the mesh number 7, object number 7. Object number 7 attached to object number 6. From mesh 8 to mesh 13, give the dummy.x. Leave it to state the limitation of the 6 axis. The last 3 starting from mesh 14 to mesh 16 RGB arrows, the original arrows, and attached to the tool object 7 marked translotate 99. The system will locate RGB arrow automatically to the TCP points. That means at the tip of the tool. Okay, then we leave the last relationship between the physical machine and the virtual machine. That means the 6 axis of the motion control car's definition. Started from the first axis, the translocate is 2, is a rotation. The first J1 is a rotation, rotating around 001, rotating around the Z positive axis. The Z, then we forget the Z pivot. We have to make sure X pivot, Y pivot is 0, 0. How to do it? We go back into SolidWorks and insert the foundation MZ0 and its original position. Okay, this is the pivot point. We have to make sure the SY is 0. How to do it? We put a cursor on the edge of the circle, orange rough lines, rough circles shown on the screen. Then we simply press the left button of the mouse. The center will mark in here, the X0, the Y0, correct. Forget the Z value. So this 0, 0 verified. Then continue to the second axis of the controller. The rotating axis is 0, 1, 0, rotating around the Y axis. So we don't care about the Y pivot. We have to make sure X pivot and the Z pivot, the value is correct. How to do it? We go back to the SolidWorks as well. And then insert AJ1. Locate its original position. Okay, this is the second axis J2 rotating around. The center of the circle is the pivot point. So how we can get the position of it? We simply put the cursor of the mouse at the edge and press the left button. Then the center of the circle will state it at the button at here. So forget Y, we have to make sure X equal to 80, Z equal to 350. Let's see. $80 to 350. So here is wrong. So we have to change 50 into 80, and this one is 250, 350. $80 and 350. 80, 350. Okay, so then we continue to survey the third axis of the motion control car, which is locating around the 010, is rotating around the y-axis as well. So we leave the y value. We have to make sure this one and this one is correct. MZ3, the same. We go back to the SolidWorks and insert the component. Okay, we commit a mistake. This one is Eurotech, it's not the MZ7. So we change the value. It's not correct. So we go back. To do it again. Okay, how to go back? Remove everything first. Close the file, no saving, and open an assembly file, vacant assembly file, and insert from D and NACHI MZ07 and open it with the correct folder and start it from the foundation MZ0. Open it at its original position. Okay, then to see the center, rotating center of the J1. Okay, support this one. Highlight and press the left button to see the first one, 00. Okay, so the first axis, X pivot, Y pivot, 00, correct. Then we continue to do MZ2. This is MZ0. MZ1, MZ0. This is MZ1's rotating position. And then we can get the second pivot point by insert MZ1 at its original position. Okay, it's very difficult to get the center on here. Let's see if difficult or not. Press the button. You see, no center. If here we cannot get a center, then we insert MZ2. MZ2 at its original position to see the center of the pivot points. But in here is hidden by MZ1, so we hidden MZ1 by press the right button of the mouse and here to choose this function to hide MZ1. Then we pick the circle in here and press the left button of it. You can see rotating around the y-axis, we forget the y coordinate, so only 50 and 2, 4, 5 have to be filled into here. Is 50 and this is 3, 4, 5. 3, 4, 5. After that, we have to see the third axis rotating axis is correct or not. Is 0, 1, 0 rotating around y-axis is correct, and then to survey if the pivot point is correct, the 50 and the 675 is correct or not, we go back to here. Okay, rotating pivot point can adopt from here. We just simply press the left button and to see 50 and 675 correct on CSV table. 50, 675, so it is correct, and continue to go to the first axis. The first axis rotating around the x-axis 1, 0, 1. Then forget this one. To see 0 and 7 to 0 is correct about the MZ4. So we insert MZ3 at its original position. So we have to find the center between these two lines and the center from here to here, or we insert the other one to check if there is any convenient method to get the pivot points. Then we don't need to check these two x y values, these two z value, and divide it by 2 to get the center of the pivot point. So we insert MZ4 at its location, original location, and hidden these parts, and to survey if we can get the points from here. It seems impossible to get it, so we have to find the point in here. You see, you press the button in here and press it, then you can get SYZ position, and put the button in here and press the button. You can find this one, SYZ, and the center of the Z is divided, this one Z plus this one Z, and divided by 2 to get it. After calculations, we can get 720 and the y still at the center 0. Okay, this one we have to be very careful to calculate it. Okay, we don't go so fast, we do by ourselves. So this one, to get the z is 772.63. And this, okay, we use another one, the previous one. We hidden this one and view this one and calculate from here, maybe better. Let's see, better or not. Okay, I think it's better. From this point, so this is straight line to this point to see how much it is. 667.09, and this point .13, and use calculator. 773.13 plus 667.09 and divided by 2, we get 720.11. Because this one is arbitrary to get, actually it should be correct 720, because the whole from here to the front, the y-axis should be the same. Otherwise, the system cannot be calculated correctly. So simply we just insert the MZ6 to see how much the z value it is. Okay, simply press here, you can see 720, right? So this z 720 in here, it should be 720. We get the position at the top and the bottom and divide it by 2. There must be some little errors, so we keep to give the z power 720 and use the same methods. We can get the fifth axis rotating around 010, leave this one to see this one and this one is correct or not. Okay, we go back. The one is rotating around here. Oh, here's a circle. So this one cannot give the center. Okay, then we use the MZ5 to see we can get the power points from MZ5. Okay, we hidden MZ4 right in here. Maybe we can get the rotating center. Just press the left button of the mouse. No way. No way. We don't give up so early. We can find any place. Okay, in here we can see the X rotating power points is 390, the Z is 720, and 390, 720. Okay, and the flange of the MZ6 we mark already, 473 and 720, fitting correct. And the tool we talking already, we just copy it into S power 243.3, Y power 0, Z power minus 25, N1 0, rotating around Y axis 30 degrees, rotating about the Z axis 0. So after this all fitting, then we have to fit in the limitation, positive and negative, of J1, J2, J3 until J6. Now after all this column be filled, then we have to make sure the continuous last one is 2. The mechanism is the second type LOBA. So after everything correct, then we have to save it. Yes. And yes. And save MZ7 new. Save it. Yes. Yes. So after save it, then we can use our system to check the CSV file is correct or not. How to do it? We just use new to remove the model of the screen, and then use scene input to see CMS GAC data to find the one MZ7 new and open it and display on the screen. And to check everything, use teach more to check the first axis. You see, these circles not good looking, but not too much influence about our control of the LOBA. We just leave it there. We talk already, because different CAD system, maybe the model generated by UG or CADIA, after translate into SolidWorks, and from SolidWorks into Polychance, some surface get troubles. There are two parts, the MZ1 and MZ2 get a little trouble, but don't worry about it. Okay, J1 plus and J1 minus correct, J2 plus, J2 minus correct, J3 plus, J3 minus correct, J4 notating. Okay, J5. Okay, J6. Okay, then we check the Cartesian coordinate system. is correct or not. The X positive, negative, we reset it. Positive, correct. Negative, correct. Y positive, Y negative. Z positive, Z negative. Rotating around X-axis. The red arrow don't move. The thumb point to the axis positive directions. The four fingers rotating the robots. Use inverse mechanism, inverse process calculation. So it is correct. RY positive, RY negative, and RZ positive, RZ negative. It seems all correct. Now one more we have to introduce is we can use the robot setting and choose the choose function, then select 0 appear in here. Then we can use the cursor, suppose on this position, and press the right button of the mouse. Then select 1 will showing in here. That means the join 1 are selected. As the select 1 disappeared, then we can put the cursor in any position and press the left button and keep pressing the left button and move the mouse horizontal to the right. Then the join 1 will turn at the positive direction. If we move toward the left, then the negative turning will show on the screen. Okay, suppose we choose this join by pressing the right button, then select 2 shown on here, and we press the left button, keep pressing the left button and move the mouse to the right, and the J2 will rotate around the positive direction. If we move toward the left, the negative rotating will show on the screen, and the inverse process will automatically calculate it by the system. And you can pick the RGB arrow as well, or simply put a cursor and select the position and press the left button to increase 1, and press another left button to increase 1. 7 to see what's the select 7. Select 7 is green arrow, positive. Select 9 is blue arrow, positive, negative, positive, negative. Select 10 is rotating around the axis, positive, rotating, negative, rotating. And select 11 is rotating about the green arrow. Select 12, rotating around the blue arrow. Then you can press the right button to deduce 1. You see, each press the right button, then select 9, change to select 8. Okay. Then, quickly we finished introduce the ideas NACHI MZ07 robot, although not very good looking, but could be used. It's good enough. 走过岁月的蹉跎，迎着潮起潮落，我们为爱漂泊。爱亮的心是手中的烟火，醉人的牵挂，点起篝火，不灭的传说，前程分享一路是爱过。和你在天边不断交错，时光凝结我们的承诺。今夜多想起空空的耳廓，不愿我会一生只爱过。爱人的眼里看清情波，忘记那岁月岁月风。爱亮的心是手中的烟火，心